consider a situation, you're writing a program in high level language and your digital computer is able to execute that. So think about how that is happening behind the scene. So definitely there is some software or some program which is converting your high level language into a machine understandable form, and then your program is able to execute. So but that is also not the entirely that is not the complete truth. Actually there is lot more that goes behind the scenes, right? For example, if you consider C program, a C program gets converted to assembly language, and further the assembler reads the assembly code and generates the machine instructions, and then your machine execute the programs, right? So here comes the role of compilers. For example, you can observe this piece of code here. This is a piece of code written in C programming language, and once the compilation is successful, and you can observe at this part, these are the assembly instructions, right? These are the assembly instructions. So let me just drag it here. Yes, so these are the assembly instructions generated by the C compiler. So what happened here, this program was given to the C compiler. Once the compilation procedure was completed, this is the assembly code that is generated. Further, this assembly code will be taken by the assembler of the local machine and converted to machine instructions, and then that will get executed and the result will be given. So this is for C language, right? Similarly, if I go for, let's say, Java programming language, so you can observe first of all the high level code over here, that is a method here, square, return type integer, static method it is, and the parameter is int num and it returns num times num. And now this is the bytecode instruction that you can observe. So here for Java, the source language is Java, the Java program or the Java code as the source language, and in the target code this is the bytecode that you can observe. So you can observe this is the constructor over here from line number 2 to 5. If you can observe this selection, this is the constructor provided by default by the compiler. Java compiler provides this, and this is the method. You can see the load instruction, and then integer multiplication instruction, and then integer return, right? So these bytecode instructions are generated by Java compiler. Similarly, if you take an example of a Python program, you can observe these are the instructions. These are the instructions generated by the Python compiler internally, and this is the Python bytecode that you can observe corresponding to the high level code, right? So the study of compilers is extremely important. That is what I wanted to convey from this. So basically, what is a compiler, right? A compiler is a program. It's a giant software again for in many cases. It's a program that can read a program in one language, that is a source language, and translate it into a equivalent program in another language that is called the target language. Like if you consider the case of Java, in case of Java, the source language is the Java program and the target language is the Java bytecode. In case of Python, you can observe this is the source code of Python, like in this selection, in this mid part, if you can observe, right, in this selection part. So this is the Python source code, and if you observe the right side, this bytecode, this is the Python bytecode, and this is the disassembled version. So this bytecode will be given to the Python interpreter. So Python interpreter will read this and generate the machine instructions and execute on the machine. Similarly for Java, we have already talked about. So this is the Java source code and these are the machine instructions. Same for C language as well. So this is the source code written in C, this is the machine instruction. The same goes for JavaScript as well, right? So this is the code here, this is the source code, and this is the machine instructions or the converted form over here, right? Next goes for, let's say, any other language, maybe Scala. So this is the source code and this is the target code, right? So the source code and you can observe here clearly the Scala has similar instruction, very similar to Java, right? Java also had similar kind of bytecode, integer load, integer multiply, and then local variable table is there, and so on, right? So what compiler does essentially is it will take the source language as an input, and then if there is no error whatsoever at compiler level, then it will translate it into equivalent program. Why equivalent program? Because the program that is written in the source language, the computation that the source program is performing, the equivalent program has to be produced by the compiler as well. So compiler is itself a program which converts the source language, that is from one language, to the target language. So that's the answer. Assembler is also a type of language translator which converts the source language to target language, right? Now if you observe this levels of hierarchy here, so digital logic microarchitecture instruction set, so this covers This is covered under the course of digital logic and computer organization, computer architecture, and computer design. Operating system is something which we'll brief upon in the upcoming discussion. Assembly language is something that is the input for an assembler. Assembler reads the assembly language, like in this case of C programming language, you can observe this is the source code. From this source code, the assembly language is generated. This assembly language is consumed by the assembler, and then assembler converts into the appropriate machine instructions, and then the underlying hardware with the help of operating system executes the code. And at level 5 somewhere our this compiler is there, which bridges this high level language to assembly language, right? And further the assembler takes care of the other thing, right? So this one I have taken from the textbook of Tannenbaum and Austin. Okay, so very beautiful diagram which connects the core computer science courses in a very beautiful manner, right? Now, why anyone should study about compilers? So it's crucial for anyone who cares about performance, because if you are aware of the assembly instructions or the bytecode instructions in case of Java, you can write better optimized code, right? It is key ingredient in modern processor architecture. Like the rate at which the LLMs are getting resource hungry, we need to have better processor architecture in our upcoming days. So one having a sound knowledge in compilers can exactly mention that what kind of processor or what kind of ISA must be designed, so that the processor provides the support in such a way so that with minimal resource consumption maximum amount of output can be given, right? And compilation is the heart of computing. This maps the high level abstract machine to low level one, right? So a digital computer which understands only zeros and ones, compiler is the one which bridges this formal mathematical language into zeros and ones, and we are able to execute the programs and get the results. So these are some of the very critical components that one should carry as a motivation to study about compilers. Now the thing is that the other valid question that comes from the undergraduate student is that where are the jobs from this one, right? Obviously these reasons are there, that you will be able to perform better static analysis, your debugging skills will increase, you will get to know about scanning techniques, parsing techniques, instruction selection, okay, you will be able to optimize code. But when it comes to the question that are there jobs on this one, the answer is indeed yes. So if you observe, this is a portal where LLVM from LLVM Foundation, these are the available jobs. So Apple as the company, so they focus on compilers, they have this. So with LLVM being the basis of compilers, so based on this they have jobs, and these are the contacts you can observe, right? So the title is Senior Apple GPU Compiler Backend Engineer. So compilers are indeed used here. Then next, there are like Modular. This is also an organization where they need compiler engineer, AI compiler engineer, right? So people have not even heard about these terms mostly when I talk to them. AI programming language engineer. So one need to have a sound knowledge in compilers. As you can observe, it's mentioned in compilers, right? So you can see all this yellow highlights where definitely this word compiler is marked over here in these situations, right? Correct. So these are the job openings based on compilers. Huawei is one of the organization. Okay, senior compiler software engineer, MathWorks, right? Then Media Tech, right? So compiler architect. So definitely jobs are available in the industry. And most importantly, if you observe the software engineering interview prep guide of Google, right, which is a dream company for many, again your job should be the most important for you, right? So you can observe clearly that even this company Google mentions the word compilers, and there are many other companies I can name them, DShaw, Amazon, and lot more companies which requires engineers to have knowledge on compilers, right? And not only this, if you observe, as a computing foundation, if your foundational knowledge is good, you are claiming that thing, so companies do expect compilers from you, right? So that's definitely the part. So I hope this should be a good enough motivation to study about compilers, right?